Hello, my name is Justin Wilson, and I'm a senior data scientist in MITRE's Transportation Innovation Center. Today, I'll be presenting our presentation on extending a big data platform for transportation to space. A core responsibility of our department is to operate a big data analytics platform. We call this platform the Transportation Data Platform, or TDP for short. My co-authors are Adelfio and Hare. Together, we make up the subset of our team currently working on extending TDP for space. I will start with an introduction to TDP and why MITRE decided to develop this big data analytics platform. Then I'll provide an overview of what is TDP, including a brief description about the people, process, and technology used to develop and support it. And finally, I will highlight some extensions that we've made to the platform so far for space and potential collaborations in the future. Please feel free to contact us directly if you'd like to learn more. Marco is a principal data scientist for TDP, and Dan is the group lead and product owner of the platform. Contact information is on the last slide of the presentation. Okay, so let's get started with why MITRE decided to develop TDP. The diagram to the left is an example analysis process before or without TDP. So imagine that you're a data scientist or data analyst tasked to do an analysis with aviation and or space data. First, you have to locate the data within your organization or purchase it if it's not publicly available. This can be costly from time lost or duplicate data purchases. Once you have access to the data, you may need to prune or filter it down to a manageable size. Transportation systems can produce large, complex data sets, which is where big data capabilities are needed, which can scale up computing resources as needed. Next, data preparation in the form of scrubbing, fusion with other data sets, and generating derived data or metrics is needed. Finally, after these processing steps, you can start your analysis. With tight deadlines, this often leads to limited time to coordinate or share best practices, which may lead to duplicate efforts or inconsistent results. This can also lead to data silos or data islands that are managed independently. Each having its own technology stack requires skills and expertise. In summary, without coordination or reuse, teams may be reinventing the wheel. The figure to the right is the analytic process with or after TDP. We brought data islands together into a common big data analytics platform for consistency and reliability. First, as the analyst know, the data is available in TDP. And if it's not, you can ask our community of developers or analysts, and we can work together to incorporate it for next time and others to use. There's a consistent process for scrubbing, fusion, and deriving metrics, and it's an automated process that's run daily in TDP to prepare data for use. The process is transparent, data and code is accessible, and can be improved and matured as a community. Analysts start at the analysis step right away. Everybody's starting at the same spot, singing from the same sheet of music. Same data, same code libraries, same tools, and same documentation. The figure to the right is an operational view of TDP. In the center of the graphic, we have a multi-petabyte Hadoop cluster or enterprise data warehouse. It currently processes over 40 different data sources with varying data formats daily in the platform. For aviation, TDP has processed an archive of 10 years, over 10 years of data. And for space, a year has been processed so far with the ability to access historical data or other data sets based on business needs. The bottom left of the figure shows the ability to access data on premises or in the cloud using Jupyter Hub notebooks in R, Python, and other languages. The bottom middle of the graphic shows about almost half of MITRE projects for the Federal Aviation Administration using TDP. And then the bottom right is our REST API and services, which enable dashboards to be driven by TDP data. Some other highlights, it's evolved over the last decade, mainly for FAA work, but we can benefit other domains without the same upfront time and cost that was needed to get TDP where it is today. It's a collection of services, so it's not just the hardware that was mentioned. It's software code developed at MITRE, scalable data science environments, and access services. It's built on an extensible architecture using open source technologies, allowing the platform to continue to evolve. And although the systems called the Transportation Data Platform We've mainly focused on aviation until early this year, but a lot of the software and architecture is domain agnostic. TDP is extended to support space, which we will now discuss. So in addition to engagements to understand current needs and capabilities, we've started to prototype space in TDP. The current state of our prototype for data includes processing from spacetrack.org for orbital mean elements, the Unified Data Library for observations and conjunctions, and the International Laser Ranging Service ILRS data. The figure at the top right of the slide shows our automated workflow that processes the space data daily. You can see the 4 data sources at the top. We have also prototyped an orbit change detection method, which shows the platform's ability to generate derived data sets from the raw data. Derived data are depicted as ovals in the directed acyclic graph of that figure. The bottom right figure shows an example notebook that allows analysts to quickly access and analyze data within TDP. We've been able to reuse many of the existing tools within TDP. For example, the Jupyter Hub environment figure in the previous slide, as well as the data availability view, which we see in the top right of this slide. Data availability shows what data has been processed for which dates and the location of the data. It also shows the data versions as the platform evolves. So we've been able to use the same tools current TDP analysts are using for aviation and reuse them for space. We've also extended our tools to support the space data, such as our flight viewer in the bottom right of the slide, which now shows ground traces and associated data for each space object. We've also added to the TDP codebase by adding dependencies to internal external code for integration with others' methods. Finally, we continue to engage within and outside of MITRE to develop other derived metrics to support aviation and space use cases. Everything that we've covered in the previous slides are now available for space. To name a few of the initiatives that we support now or in the future, include discussions with preservation of space domain and the surface to space for retrospective historical analysis and planning, MITRE's Enterprise for Space Analysis, known as MESA, for data integration and simulation, and Office of Space Commerce project teams, possibly for data repository and cloud services. These are all still exploratory at the moment. We're also looking to connect with other FFRDCs, the UDL Data Science Working Group, SACT Observers Partners, and finally, participants of this Ascend conference. This concludes our presentation on extending MITRE's Transportation Data Platform, TDP, for space. Please read our technical paper for more details. And on behalf of Marco Van and myself, we'd like to extend our thanks for the opportunity to share our work and look forward to hearing from you. Thank you very much.